Good day, I am Michelle C. Castillo from BS Ed Math 3A, and today I'm going to present my geometric model named Octoflakes Blades Geometric Model. And this is my model. This is the front and this is the back. So at the front, we have M, A, B, C, D, E, F, and G. While at the back, we have S, T, U, V, W, X, Y, and Z. So at the front, we have N, at the back of it is S. At the front, we have A, at the back of it is Z. At the front, we have B, at the back of it is Y. At the front, we have C, at the back of it is X. At the front, we have the D, at the back of it is W. At the front, we have E, and at the back of it is V. At the front, we have F, at the back of it is U. At the front, we have the G, and at the back of it is the T. And here are the movement that correspond to each letter. So for N, we have do nothing. For A, rotate 45 degrees counterclockwise. For B, rotate 90 degrees counterclockwise. For C, rotate 135 degrees counterclockwise. For D, rotate 180 degrees counterclockwise. And for E, rotate 225 degrees counterclockwise. For F, we have rotate 270 degrees counterclockwise. And for G, rotate 315 degrees counterclockwise. And for S, flip vertically. So we will flip the model vertically, and that will give us S. Then next, for T, flip between the left diagonal and vertical axis. For U, flip about the right diagonal. And this is what U looks like. Then next, we have V, or flip between the left diagonal and the horizontal axis. Then next we have W, or flip horizontally. So here, we will just flip the model horizontally, and that will give us W. Then next, we have X, for flip between right diagonal and horizontal axis. And this is what X looks like. Then next we have flip about the right diagonal for Y. So this is what Y looks like. And lastly, we have Z, or flip between right diagonal and vertical axis. And now, let's operate this. So let's start with N. So N star N is equal to N. Since when we operate do nothing to itself, do nothing, the result will always be N, or do nothing. So here, we just copy the outlines for the column and for the row, since N is a movement for do nothing. So when we operate do nothing to other elements, the other elements will be the result. For example, N star A is equal to A. Then N star D is equal to D. Same as with D star N, the answer will always be D. Then next we have A star A. So when we rotate this model to 45 degrees counterclockwise, we'll get an answer of B. Then next we have A star B. So when we rotate this model to 90 degrees counterclockwise, this will be the result. So A star B is equal to C. Then next, we have A star C. So when we rotate this model to 135 degrees counterclockwise, the outcome will be D. Then next we have A star D. So when we rotate this model to 180 degrees counterclockwise, we will get an answer of E. So A star D is equal to E. Then next we have A star E. So when we rotate this model to 225 degrees counterclockwise, the answer will be F. So A star E is equal to F. Then next we have A star F. So when we rotate this model to 270 degrees counterclockwise, the answer will be G. So A star F is G. Then next we have A star G. So when we rotate this model to 315 degrees counterclockwise, we will have an answer of N, or do nothing. So when we continue this process to all elements, we will have this table of results. Since we have table of results, let's now check if this table form group structure. So to classify this table as a group structure, the following condition must be satisfied. So we have 4 conditions. First, closed anti-binary operation. Second, associative. Third, has identity element. And the fourth condition and last condition has inverse element for all. For the first condition, is it closed? Is this table closed? So as you can see here, the resulting elements of this table can be found in the set N, A, B, C, D, E, F, G, S, T, U, V, W, X, Y, and Z. Therefore, this table is closed. For our second condition, associative, to confirm that this table is associative, let's flip the table by 180 degrees. And the flip table must be the same as the arrangement of the resulting elements in the original table. So let's flip it by 180 degrees. So as you can notice, this table is not yet the same as the original one. Thus, we have to rearrange the columns. So first, let's rearrange or interchange the second and the 8th column, or the A and G. So we have this. Now, A is at the second column while G is at the 8th column. Then next, let's interchange 3rd and 7th column, or the B and F column. So in this, the B is now at the 3rd column while F is at the 7th column. Then next, let's interchange 4th and 6th column, or the C and E. So C is now at the 4th column while E is now at the 6th column. Then interchange Y and S column. So S is now at the 9th column while the Y is now at the 15th column. Then next, interchange 10th column and the 14th column, or the X and T column. So T is now at the 10th column while X is now at the 14th column. Then next, let's interchange W and U column. So U is now at the 11th column while W is now at the 13th column. And as you can notice in this table, this is our original table and this is the flip table. Since the arrangement of the resulting table or resulting elements from the original table to the flip table is the same, therefore we can conclude that this table is associative. The next, for our third condition, it has identity element. Since there's an intersection of the row and column that are the same as the outline, identity element exists, which is the element M, and therefore this table satisfies the third condition, which is has identity element. Then next, our last condition is inverse element for all exists. So for N, from N to identity element N to N, therefore the inverse of N is itself. Then next, A, from A to identity element N to G. So A inverse is equal to G. Then B to identity element N to F. Therefore the inverse of B is F. So from C to identity element N to E. Therefore the inverse of C is E. Then from D to identity element N to D. Therefore the inverse of D is itself. Then E to identity element N to C. So the inverse of E is C. So F identity element N to B. So the inverse of F is B. Then next G, from G to the identity element M to A. So therefore the inverse of G is A. Then S and S. So S inverse is itself, same as with T, its inverse is T. Same as with U, its inverse is U. Then the inverse of B is itself, same as with W, inverse of W is W. The inverse of X is X. The inverse of Y is Y, and the inverse of Z is Z. Therefore, this table satisfies the fourth condition, which is it has inverse element for all. And since octaflix blades satisfy all the four conditions, it is closed, it is associative, has identity elements, and has inverse element for all. Therefore, we conclude that octaflix blades is a group structure. That's all for this presentation. Thank you for watching, and thank you for listening.